Alright, now we're doing BC Calculus, Polar, examples 3 through 6. I am aware that I did skip 5, sorry. But we're doing 3 through 6. So it says, let the point P have polar coordinates r theta and rectangular coordinates x, y. These are important. Okay, you need to commit these to memory. This is how you go back and forth from rectangular to polar and from polar to rectangular. X equals r cosine of theta, y equals r sine of theta. That should be familiar because that's just like parametric. R squared equals x squared plus y squared, and tan of theta equals y over x. So we're going to use these to go back and forth. I do not feel like I left myself enough room here to do this, so I'm just going to do it up here. For A, it says find the rectangular coordinates of the points with the given polar coordinates. 3, 5 pi over 6. So this is my r and this is my theta. I want x comma y. So I want r cosine of theta, comma, r sine of theta. So I'm just going to make it r, 3, cosine of 5 pi over 6, comma, 3, sine of 5 pi over 6. The cosine of 5 pi over 6, that's in my second quadrant. It's a pi over 6, so it's square root of 3 over 2 negative. So this will be negative 3 square root of 3 over 2. And then sine of 5 pi over 6, well, that's a half, and it's positive. So that's 3 times a half, so that's 3 halves. And I've converted my point from polar to rectangular. I'm going to omit B because it's in degrees, and we don't do anything in calculus in degrees. You would do it the same way. Okay, it says find two polar coordinate pairs for the points with the given rectangular coordinates. Well, negative 1, 1. This time it's given me my x and my y, and I want to convert to r and theta. Well, the first formula I'm going to use is r squared equals x squared plus y squared. That's going to give me my r. Okay, so r squared equals negative 1 squared plus 1 squared. R squared equals 2, so r is the square root of 2. So that's the first part. I need a theta. Well, to do that, I draw a triangle where at negative 1, 1. So left 1, up 1. Negative 1, 1. Pythagorean theorem gets me the square root of 2 here. And my formula is that tan of theta equals y over x. Well, tan of theta equals 1 over negative 1. So where is tan negative 1 in the second quadrant? Tan is negative 1 at the pi over 4 angle, and the pi over 4 angle in the second quadrant is 3 pi over 4. But it asked me to find two polar coordinate pairs. Well, if this point is at 3 pi over 4 going out a positive square root of 2, could I tell it to go this way, same angle, a negative square root of 2? That would give me the same one. So what is this angle? Well, I think it's negative pi over 4. So it's negative square root of 2, negative pi over 4. Okay, I'm going to do the same thing here. I need my r. So r squared equals x squared plus y squared. So r squared, 9 plus 0 is 9, so r is 3. So it's going to be 3 comma. Now negative 3, 0. This one's going to be pretty easy. 0 degrees is here. Negative 3. That's going to be at pi. Or, going the opposite direction, going this way, that's 0, but it would be a negative 3. Okay. Continuing on. Convert from rectangular to polar. Again, I'm going to use my same formulas. I know that x equals r cosine of theta. So instead of x, I'm going to put r cosine of theta equals 5, and I'm going to divide. I'm going to solve for r. So you could either say r equals 5 divided by cosine of theta, or sometimes you'll see it written like that. This one's a little more tricky. Everywhere there's an x, I'm going to put r cosine of theta. Everywhere there's a y, I'm going to put r sine of theta. And then I need to solve for r. So if I I don't necessarily have to distribute. Can I factor out an r? I'd have 3 cosine of theta plus 4 sine of theta equals 8. And I divide by 3 cosine of theta plus 4 sine of theta both sides. Plus 4. Yes, and I'm aware that I skipped example 5. There was no example 5. It's okay. So there is my r equals this. The last one is a little trickier. Everywhere there's an x, I'm going to put an r cosine of theta. Everywhere there's a y, an r sine of theta. And I need to solve this thing for r. Well, I need to fold this out. When I fold this, I get square the first, double the product, so that'd be minus 1 of these, so double it, minus 2 of these, plus 1. Fold again, square the first, double the product 4 times, be 8 plus 16 equals 17. Let me double check myself. Looks good. Okay. I have a 1 and a 16 on this side, a 17 on the other side. They're all going to cancel out. 16, 17. And then, can I combine these two together and factor out an r squared? Minus 2r cosine of theta plus 8r sine of theta equals 0. This you should recognize from pre-cal. Sine squared plus cosine squared is 1. And I'm going to go ahead and move these to the other side. That'll be a positive 2r cosine of theta minus 8r sine of theta. I need to get all my r's on one side though. Can I factor an r out over here? 2 cosine of theta minus 8 sine of theta. And divide by r. And I'm done. 2 cosine of theta minus 8 sine of theta. Stop.